My name is Deepak, and I work as a principal scientist at Adobe, and I specialize in building products 0 to 1. Previously, my team was responsible for bringing Adobe Gen Studio to life, and currently here we are working on a new agentic tool for SMB marketers. The topic of today's talk is demystifying AI agents, going beyond the buzzwords to cut through the noise and see what these actually are. And our previous speaker talked about it a little. I'll try to go a little deeper and lay out the concepts in simple terms. Last year, this year, if there is one buzzword that every one of us have heard, that is agents. Every pitch deck, be it a startup or a large enterprise, has been, we are building an agentic platform to do X, Y, Z. And rightly so. However, if you talk to people who are actually building these agents, you realize that there is a lot of hype. There is overuse, abuse of the word agents, agentic framework, and many a times these are glorified function calls that we have all written as programmers. If there is one thing that I want you to take away from this talk is LLM is the brain behind an agentic system. However, LLM is brain in a vat. It does not have the ability to sense or act. And that's where the agentic architecture framework agents come into picture. Agents are basically tools in some form. We will talk about what those forms are. Agents are LLM given access to some tools to sense and act. Humans, for example, have a brain with some amount of memory. And we have our senses, eyes and ears and skin, hands, to perceive and to act. Similarly, LLMs have their knowledge, which is restricted to the training data that they've been trained on. To be able to perceive, which is to get access to fresh data. For example, if you were to ask a question, how's the weather today? The LLM does not have that information on its own. It has to access some API, some tool, some function, which gives it the latest information. So once it has access to certain information that it perceives, then LLMs are pretty good at reasoning and summarizing, synthesizing on top of the data, the context that is given to them. So for example, if I ask a question, what kind of dress should I wear today? It can look up the weather and say, okay, it's cold, it might rain, you might want to take an umbrella, all of that. And finally, the ability to act, which is again exposed via certain tool calls to the LLM. So we look at different constructs for the LLM to be able, for the agents to be able to perceive and act. The first ones are our traditional function calls. Vanilla, simple, modular pieces of code that have existed since the advent of software engineering. For example, if you were to add two numbers, very simple example. Every programming language has a construct or plus operator that helps you do that. You don't need an LLM, although I have seen people asking LLM, here are two numbers and write the best prompt to be able to add two numbers. No, that is not an ideal use case. And more so given the current cost of how much each response from LLM adds, it's not the ideal use of time and money. Another example might be, let's say you have a piece of text, a contact page from a website, and you want to extract an email address, a phone number. A simple regular expression that has existed is probably a better bet at trying to do that, as opposed to throwing it at the LLM and asking it to extract a certain regular expression pattern. However, where an LLM is better suited is if you have the entire website, sitemap, and you want to ask, hey, given this website with all the links, can you help me identify where the contact page is? LLM is probably better at doing that job. Okay, functions, let's move on to the next one. Vanilla API calls. Functions are modular enough, but if you want to expose those functions to someone outside the team, a third party, you typically wrap it around in an API call. It's pretty standard stuff. You have a request response format, and you can deploy it and make that available. Where would one use API calls? The example that I gave, I want to invoke see what the temperature is today, what the weather forecast is. I'll probably not try to implement it myself. I'll use an API from a weather service provider to fetch that information. Asking an LLM is not going to give you the right answer because it does not have it unless it has an ability to search on its own. Third one, LLM. As I said, once it has the right information, ability to reason and plan is something LLMs are pretty good at. If you want to, for example, summarize a large document, if you want to translate it from one language to another, those are ideal tasks that you would ask an LLM to do. However, we should also be cognizant that every LLM call, and it's gotten more expensive with the newer models. If you want a thinking model, a large model, the costs are higher. There is non-determinism that is involved in the responses that you gave. You're not going to get the same response every time you ask, and it's going to add certain amount of delay. If you ask a fast model, it's maybe a couple of seconds. If you ask a reasoning thinking model, it's of order of few tens of seconds. So in cases where you want fast, cheap, reliable, deterministic answer, that is where you would fall back to a function, an API call, and where you have more complex tasks is where you would use an LLM. Finally, we have what are called MCP, and this stands for Model Context Protocol. This basically helps enterprises expose the APIs that they have, the tools that they have, to external parties. And the reason that they would want to do this is, why not expose the raw API themselves, right? The challenge is, raw APIs are more built for trusted environments. And LLMs inherently are non-deterministic. And there is less control you have on what LLMs might end up doing without significant human oversight. And there are cases where people have installed OpenClaw and it has deleted their data, it has corrupted their data, and all kinds of things. We want to be cognizant of what control we give to the LLMs. It's also hard to expose hundreds or thousands of APIs to an LLM and expect that it will make the right determination on picking the right API, formatting the request that is required for the API, and ensuring that the response is handled appropriately. And reliability, security are a major risks. Hence, enterprises typically expose these functions, tools via controlled environment using MCP. So there is audit that you can do over MCP. You can manage discovery of the tools that are available, and you can control what functionality is exposed to the LLMs. Now that we have seen some of the basic constructs of an agentic system, we can look at where we might use LLM or agents versus traditional, where not to use them. First off, the recommendation is that we use agents where the task is inherently multi-step and complex. It involves reasoning. For example, if I am a small business and I want to ask the agent to research my competitors and analyze their strategies, what are my competitors doing, and give me, and how can I adapt to it, how can I counter it, give me 3 strategies, right? So LLMs by themselves will not have this information. Agents can search the web, agents can synthesize all of that data that they find on the web and be able to, and knowing what I do, what my business is, they can give me a good strategy on how do I take the next step. Second, when the tasks are inherently open-ended or dynamic. For example, can you monitor my social media and tell me if there is a new trend that has emerged, right? Punch the monkey, for example. Can you identify such new trends and not just identify, but also tell me how I can leverage it in my business? And people have done that. For example, there are airlines that have been leveraging Punch the Monkey and trying to create a campaign to sell tickets to Japan, and so on. And another example could be monitor my social media and tell me if there is some positive comment that I'm getting on a new product that I launch, if there is a negative sentiment. So being able to monitor, being able to analyze the incoming data and categorize it as positive, negative sentiment, all of that, and notifying me, and also giving me a recommendation on how to address that is something LLM and agents can do better. Tasks that involve unstructured data, natural language, text, images, that is a good fit for where an LLM can parse the unstructured content and be able to reason and act on that. And finally, where there is tool use that is required. So we have different things like browser use, running a piece of code, accessing a live database. So in cases where you have various tools that need to be used in a non-trivial combination, which is more complex than a naive workflow automation, is where an agentic system is a good fit. Where are agents not a great fit? If the task is simple and single shot, right? Like add 2 numbers, simple function, not an agent. Workflows that are predictable. Workflow automation has existed for decades. And if there is a known workflow where we know that things need to happen in certain order, in certain steps, and each of those steps are deterministic, it's preferable, better to retain that determinism and not have an agent try to automate it. Finally, a high-stakes environment where there is ethical judgment that is involved, legal, medical diagnosis. It's always better to have a human in the loop than have an agent make autonomous decisions. So now we have looked at agents, where to use them, where not to use them. Let's look at how the agentic stack looks like. The 2 important concepts that we need to know in addition to the basic constructs are MCP and A2A. We looked at MCPs briefly, right? Model Context Protocol. They give agents access to the tools that help them perceive and act. These are horizontal capabilities where the tools, APIs are available to the agents so that they can perceive and act. However, in the current scenario, it's not conceivable that a single agent can do a variety of tasks. Typically, the agents are more reliable if you provide a specific if you can get very specific in terms of the instructions, the system prompt, the user prompt context, and so on, as opposed to expecting a single agent to do a variety of tasks. And that's where a second construct is more reasonable to expect, wherein you have multiple agents doing specific tasks. And each agent has a very focused objective that it is very good at, and not trying to be a jack of all trades. For example, if coding or building software is a task, it's natural to expect that there is an orchestrator agent which is breaking up the complex task into simple submodules. And each coding agent is picking up one such task to code something up. And there are agents to write test cases and run these test cases to ensure that things are in order. A2A protocol is the language that agents use to communicate among themselves and achieve this coordination. So, putting it all together, we have LLM as the brain of the agentic system. It has access to tools, MCP, A2A, to sense, perceive, and act. And the LLM as the brain is responsible for planning and execution. If there is a second thing that I want you to take away from this talk, which is today agents are not 100% reliable. They're not perfect. And in my experience of using coding agents, for example, I've spent more time debugging and fixing errors that are made by the agent as opposed to if I had written the code myself. And when agents do something, they hallucinate, they give a response as though it's perfect and they're very confident about it, right? So you tend to trust them until you realize that it's not trustable. As an example, I once asked the coding agent, without naming which one, to write some piece of code, and it wrote a comment to do this. In another instance, there was an exception that the code was throwing, and I asked the agent to fix something. It nicely commented out that piece of code which was throwing the exception and said everything is now fine. Functionality, no one cares. Hopefully that was a useful talk to get a sense of what agents are, what's the difference between LLM and an agent, where to use and not to use the agents, and I can take any questions. Thank you. Yes, that's it. If there are no questions, thank you. Okay, there is. So if I understand the question, is it if I am a developer who's building and who's creating an agent? Okay, so right. Thanks for your question. So that's something that we have been working on, and the way I tend to think about this is first identify what are the tools that are required for the agent to execute, right? So identify and build the most granular of the tools. For example, if I'm building a marketing agent, I probably need a tool to scrape a website. I probably need a tool to analyze and do SEO optimization. I need a tool to post something on Instagram. I need a tool to analyze the engagement that I'm getting on Instagram. So I would first start with identifying those tools, and the next set of things that we would need is skills. Skills basically tell the agent how to do something. You have all these tools, And if you were to create an Instagram campaign, or more basic than that, if your objective is to increase engagement or increase awareness of your product, then you have to generate, or you have to post consistently on, say, Instagram, right? And to be able to do that, you would use tool 1, 2, 3. 1 maybe to create content, 2 maybe to create hashtags, 3 maybe to create captions, and put it all together, and then use this tool, which is an API, to post content onto Instagram. So I'll start with tools, then look at what are the skills that are needed, and then put this all together. Of course, there's the model part, but model capabilities always keep changing. Every other day, there is a new model that is on top of the leaderboard. So have some evals around what is the prompt, what is the expected output, and is it changing drastically day over day, and plug it in together, if that helps. Thank you.
Very clear presentation.
Thank you.
And in your last slides, you mentioned that we should not trust AI blindly, and you give some example for the AI coding. But we know that different tools, different LLMs can give different results. Some is good, some is bad. So any suggestion on these AI coding tools? Have you ever compared different AI tools?
Again, there's no simple answer to that, because the capabilities of these tools change on almost every day basis. So yesterday, maybe Cursor was the best available coding agent, and then Codex, and then Claude, and so on. At least things have gotten much better in the last 3-6 months, as opposed to where things were a year ago. And there's no single answer of this is the best tool, and this will be the best tool for the next 6 months. We have to keep trial and error. And the other problem with the coding agents and tools are the token limits and the cost. So every organization has some limit and restriction on the cost per developer, on the tool usage, on the number of tokens, and so on. So we've had people orchestrating multiple tools, multiple models within the tool to manage the tokens and the credits. So for example, the way I would do is if there is I would try to use a single surface so that it's easier for me and adds lesser cognitive load, rather than trying to switch between 3 different surfaces, Cursor, Claude, and other things. So I'll try to maintain one surface, use multiple models, plugins within that, and look at what tool makes sense for what job, right? And what I mean by that is, if you're asking a simple question, writing a simple function, you're probably better off using a fast, cheap model, as opposed to writing something which is more elaborate, complex, maybe an entire file, or something that is spanning multiple files, more complex flow. So that would be my way of going at it. Sure.
Just to follow up on that, you said very good phrase. You said sometimes it took you more time to debug and to correct what that agent did, as opposed to if you coded it all yourself. Mm-hmm. So I also code a lot with agents, so I have the same sometimes opinions, and also prompting and iterations and then debugging of the agent took me more time in terms of efficiency than if I just did it myself. So how do you manage, like, we all want to be more efficient with AI, right? But now I see that it's not necessarily happening because of that issues. Like, how do you manage, decide maybe what to do yourself versus, or what to store and do it yourself versus do it via agent, to make sure that your efficiency grows and not drops?
Thank you. Thank you for the question. That's a good one. The way I think about this is there are certain areas that I have expertise in, and I would try to do it myself. There are certain, for example, if it's a simple module, I'd probably code it up myself, right? Even autocomplete is reasonably helpful enough than trying to ask an agent to write that piece of code. Where I do use agents is, let's say I have to look at a wiki page and understand the API spec and all of that. It's too much reading, which is probably better off handing off to an agent, because it can definitely read a few pages of document much faster than me. And it can faithfully reproduce the API spec of request and response and all that, and create a HTTP request to make that API call. So in that use case, I definitely use an agent, and it makes things faster. If something is not within my area of expertise, for example, I'm a more backend developer, and I know very little of frontend. But there are more front-end engineers on my team who have built a structure, a reasonably large code base for what we want to do. So if I were to add an incremental minor feature, a small button here, which on click should do something, and do that in TypeScript, which I don't understand, or use React or other framework, which I don't know, I'd rather have the agent do that. Because it can identify the existing patterns in the code base, the architecture, and do these small tasks reliably, easily enough. And I would still route it to the people on the engineering team who are experts on the front end to review it and make sure that it's doing the right thing. So that's my usage. Yes, sir.
Do you have any tools today to evaluate the cleanness and availability of the data?
To evaluate what?
Data sources, talk about tools and agentic, everything is great until you need to access data. Data is all over, it depends on the agent and where he gets it, but is there anything that you use today to evaluate the data is clean, it's accurate, and it's available in any measurable way?
That's definitely a useful problem. More so, there are two variants to it, right? One is if you're training LLM or any kind of model yourself, the data that you're giving it to train, to fine tune, you want to ensure that it's of good quality, the labels are correct, and so on. The other is where you're essentially operating in the space of prompt, and you want to make sure the model is fixed. It's some third-party model that you have no control over, but you're giving it a prompt, and you want to make sure that you get the right response. Given the current setup of our system, where we are trying to go from 0 to 1, we are not as much focused on the data. We want to get product market fit, so that's where we are. But for a more sustainable existing product development, there are tools like, for example, we have used Langsmith as an example, where you can build a data set and you can run your automation of prompts. And similarly, if you're training, fine-tuning the model, there are third-party, and I have to look up the names, but there are third-party that provide you help with data annotations that help you create the data sets, where you can run regular tests and measure any kind of performance metrics, whatever is appropriate across different runs of, say, if the model changes, if the prompt changes, and any component of the setup changes. There was another question. Yes.
So going back to the previous question about coding with agentic tools, one of the things that I've noticed, obviously in interns that I work with, that they heavily rely on Cloud Code or Codex that my company relies. And I feel when I speak to them, they don't have the intuition behind building like even simpler CRUD APIs. How would you go about actually trying to have a trade-off between them building that expertise, which you talked about, and using agentic systems to build it? Because I worry that without doing it themselves, they won't actually get to the expertise that you have, even with myself.
So I think we are running out of time, so I'll take that question offline. Sorry.
Okay, thank you.
Thank you, everyone.